Often NASA must launch for the weather, rainy weather, cold weather. In this case, SpaceX needs this to be, your space station to be operable in emergency situations. So your challenge today is, how can you create a warm temperature bath so that your rocket will last, or will launch as quickly as possible for the least amount of money? So you've got to create a heating mechanism to do that. What do you think will be the biggest challenge? Will it be keeping the cost low or having the reaction happen quickly? Akshay.
Having the reaction happen at the correct time. Because we need the heat, but then launch was also right out. Because if it doesn't happen there, then we're under the second, over the second. The rocket doesn't launch, the rocket's frozen.
So today it's just so the launch is quickly as possible. You're anticipating the exhibition, and in fact, where maybe you have to launch within a certain time period. So you're getting the harder problem that you have. Agree with Akshay or disagree? Is it harder to make it heat or to do it at a low cost? Making it quickly or do it at a low cost? Charlie?
I think it's extremely difficult to make it heat well, because I think heating quickly would be pretty easy, but to get the reaction actually to work, because half frozen water just with melted reacting with something won't react nearly as well. And so I think the main problem and the main concern I have is that we're going to get everything right, we're going to be able to heat it up, but the reaction is going to happen when there's when it's really cold water, and so it won't go off because it's too cold to react.
So you're going to have some of the water may still be ice, the water there is going to be cold, it's going to start throwing off some of the reactions. Has anybody come to any conclusions about the connection between the two water tanks and heat transfer? So in other words, what's the equivalent of being high versus low? If it's delta height with the water tanks or changing volts or voltage, what is it for heat? What makes these flow from one place to another? Anybody come to a conclusion yet? This may help you. What about
Well, I just have a theory. I mean, I think we all know that when molecules heat up, they start bumping into each other, and they go faster as it heats higher. So maybe the way that the heat is transferred is because of that motion. I don't know.
If that's true, I'm going to transfer heat from one item to another. Do the items have to be touching?
They don't have to be touching because heat can be transferred through air too. Even though air is a really bad substance to transfer heat through.
So, last question. What would be your biggest challenge today? You've got to conduct this experiment. You've got to do it in inclement weather. What's your solution for that? Do it indoors, do it out on the back porch, do it in a covered area. Charlie?
I think I'd do it under a covered area and take the cover off right before the launch. Because if you can fine-tune it, you know when it's going to launch between a certain number of seconds, you can take the cover off right before it launches. So it's so that it's dry and there's no rain in the way right up until the cap pops off.
So I would encourage you today to spend time with your teams working out the chemistry of this. Just thinking about how heat actually flows and the chemistry behind it is going to save you oxygen. Oxygen's already figured out that as we come to the exhibition, these problems are going to get harder and harder. The team with the most fundamental understanding of what happens in chemistry and temperature is likely to have the advantage when the conditions change, just like happens with real astronauts. All right, well, good luck this afternoon, and may the melting begin.
Good luck.